Say you are given x plus 3y equal 4 and 2x plus 7y equals 13. This is a pair of linear equations, and how we solve them simultaneously for x and y. We can do this with different methods, but here I'm going to show you 3 methods by which you can do this. And these 3 methods are solving by substitution, elimination, and using matrices to solve. So let's start with substitution. Let's label our equation. This is equation 1, and this would be our equation 2. Now I'm going to solve for y in equation 1. Solving for x would be a lot easier, but I will solve for y. How we do this, we subtract x on both sides. So we'd have 3y equal 4 minus x. Since we want y on one side by itself, we divide both sides by 3. We are left with y equal 4 minus x over 3. Now we will plug our new equation into equation 2. So let's do that. Where we see a y, we will replace that with this. So we will have 2x plus 7 and what is inside the bracket here. So let's do that. So we have 2x plus 7 times 4 minus x over 3 equal to 13. Now that we only have x in this equation, we will solve for x. So let's do that. So to solve for x, let me first multiply by 7. The 2x will remain plus 7 times 4, which is 28, minus 7 over 3. Well, 7x over 3. And that would equal to 13. Now let's break up this fraction. 2x plus 28 over 3 minus 7 over 3x equal 13. We're going to take the constant on one side, so we're going to have the 2x minus 7x over 3 equal 13. And since we're bringing this on the other side, what we're going to do is subtract. So minus 28 over 3. Now that we have like terms on each side, here we have x subtracting on this side and we have constant subtracting on this side, what we're going to do is to subtract these. So we subtract 2x minus 7 over 3x. 7 over 3 is approximately 2.33 going on. So if we subtract that from this 2 here, we will be left with negative 0.33, which is the same as 1/3. So negative 1/3 x equal 13 minus 28 over 3. And when we subtract that, we're left with 11 over 3. Since both sides are being divided by 3, we can rewrite that as minus x equal 11, which leads to say that x is equal to negative 11. Since negative x is positive 11, then positive x would be equal to negative 11. So keep this in mind. 11, we have 11 for x. Now that we have a value for x, we can substitute that value for x in one of the equations here. I will plug it into the first equation, which is equation 1, and solve for y. So I would have negative 11 plus 3y equals 4. This is 3 equal to 4. And we transpose for y, and we are left with y equals 4 plus 11, this is a plus sign, plus 11 all over 3. When we plug this in our calculator, we should be left with 5, because 4 plus 11, this is a 3 by the way, this would be a 3. That should be a 3. And since 4 plus 11 is 15, and when we divide that by 3, 15 by 3, we should be left with y equals 5. So the answer for our simultaneous equation would be y equals 5, x equals negative 11. And this was using the method of substitution. Now let's take a look at the elimination method. Using the same example, x plus 3y equals 4 and 2x plus 7y equals 13. Going back to the same example. With the elimination method, we manipulate one of the function or both in order to eliminate one variable. So for example, in this case, it would be easier to eliminate x. So I will show you how to eliminate x. Unlike in the substitution method, what we did, we solved for one variable, which was right here. We solved for y, then we substituted it into the equation, one of the equations. So in the elimination method, we will eliminate one variable, so we will have one variable to work with. So let's eliminate the x. What we will want to do is to manipulate equation 1. Let me label the equation. So this is our equation 1, this is our equation 2. So we're going to manipulate equation 1 so that when we add both equations, the x cancels out. Since there is a positive 2x here, if we add a positive 2x to a negative 2x, they will cancel out because they're equal magnitude but opposite sign. So let's multiply equation 1 by negative 2. So when I multiply equation 1 by negative 2, I will have negative 2x, and negative 2 times a positive 3 would give me a negative 6y, and negative 2 times a positive 4 would be a negative 8. Now we want to add both equation. Let's call this equation 3. So we're going to add both. Let me write this as a statement. When we add both equation, let me line them up so we can add. Our equation 2 was 2x plus 7y equals 13, and our equation 3 is negative 2x minus 6y equals negative 8. When we add both equations, this will cancel out. So we're left with 0x and 7y minus 6y. Even though there's an addition sign here, because there's a negative 6, it's like subtracting. So 7 minus 6 would be 1. So let's write it as y instead of writing 1y. So this would be plus y. And this now will be equal to 5. And if we recall from our first example using substitution, y was 5. So now that we have our value for y equals 5, we can plug that into either equation to solve for the value of x. So let's do that. We're going to substitute y equals 5 in equation 1. So let's write that as a statement. So equation 1 was x plus 3y equals 4. So when substituting, what you do, you plug the value for y wherever we see y in the equation. there's only one y, so we will substitute that 5 where the y is. When we substitute that 5, we will have x plus 3 times 5 equals 4. And when we multiply this, we get 15. So x plus 15 equals 4. Now we are going to solve for x, meaning we're going to make x the subject of this equation. So we'll have x equals 4 minus 15, which would give us x equals negative 11. And if we recall from the first example with the substitution, we got negative 11 for x. So using both methods, we arrive at the same answer, where y equals 5 and x equals negative 11. And this is the elimination method. When solving using the matrix method, it's like using a formula. The formula is B equal A inverse times C. A inverse is equal to 1 over the determinant times the transpose of A. So the determinant, 1 over the determinant of A, let me write that in an X form. This is a form you can write the determinant in. So 1 over the determinant of A times the transpose of A, which would be this, considering that these elements are elements of matrix A. Then we plug it into the formula here and multiply it by C. So let's go a little further into explaining what A is, what C is, and what B is. Now, if we go back to our pair of equation, x plus 3y equals 4 and 2x plus 7y equals 13. How we set this up as a matrix is by doing this. The A matrix. The A matrix is simply the coefficient of the x and y in the same order. So the 1, the 3, let me write the 3 a little better. This 2 and this 7. And we write them in the same order, and if they add signs, then we would put the signs before them. So this is the order we write our A matrix in. So this is our A matrix, and this is what we're going to find the determinant for and the transpose. Next, we want to have a matrix with our variables. That matrix is B. So our B matrix would have x on top and y, and then we'd have equal to whatever constant they're equal to, which is 4 and 13. Now let's find the transpose of A and the determinant of A, multiply them by each other, and we will have our A transpose, so we can multiply that value by our C, which this here would be our C. So let's do that in order to find B. And the reason why we're doing this is because these are the unknowns. And if we transpose for B, when we move this to this side of the equation, then this will turn into A inverse, right? So let's do that. The determinant of a matrix is given by multiplying the diagonal terms A and D and subtracting from it B times C. Let's label the elements so we can see it a little easier. So A, B, C, and D. So determinant is equal to AD minus BC. AD would just be 7 in this case, and our BC would be 3 times 2, which is 6. So our determinant would be 1. Keep this in mind. Determinant of A is equal to 1. Next thing we want to find is the transpose, which is denoted by A with a capital T up top. This is equal to this. What we do with the matrix is we switch A and D and negate B and C. So we will put D here and A here, and we will negate B and negate C. So let us do that for our matrix A. Here we would have, this would be equal to 7 in the D space and 1 here. Then we will negate the 2 and negate the 3. And that is simply how we get our A transpose. The next step is to multiply these by each other and then multiply them by C in order to find B. So let's set up that so we can find B, which is X and Y. So if we were to write it like this, X, Y, which is our B, and that is equal to determinant 1 over the determinant, which is 1, as we can see here. And we're going to multiply that now by our transpose, which is 7 minus 3 minus 2 and 1. And we will multiply this now by our C, which is 4 and 13. So let me put A transpose here and put the multiplication sign there, and the C of X, Y equals 7 minus 3 minus 2, 1 times 4, 13. Now when multiplying matrix, we know we multiply row by column. So that's what we are going to do right now. So we will have 7 times the 4 plus negative 3 times 13. In the next row, we'll have negative 2 times 4 plus 1 times 13. All of this is equal to X, Y, which is our B. So 7 times 4 is 28. So let's write that. X, Y equals 28. Negative 2 times negative 2 times 4 is negative 8. Negative 3 times 13 would give us negative 39. So we'd have negative 39 plus 1 times 13 would give us positive 13. For X, we are left with negative 11. Y, we are left with 5, positive 5. Because negative 8 plus 13 would give us that 5. And positive 28 minus 39 would give us negative 11. And as we can see, we arrive at the same answers. So this video tutorial shows you 3 ways in which you can solve linear simultaneous equations.